Welcome to the DIY Honda Garage channel. In this presentation, we will discuss the DTC P0237, specifically indicating a low voltage condition in the Turbocharger Boost Sensor Circuit for the Honda CR-V models from 2017 to 2022. The Turbocharger Boost Sensor is a critical component in the vehicle's engine management system, as it monitors the pressure of the air entering the engine. If this sensor fails or provides incorrect readings, it may cause reduced engine performance and efficiency. Understanding this fault code is essential for effective troubleshooting and repair to ensure optimal performance and compliance with emission standards. DTC P0237 indicates that there is a low voltage signal from the Turbocharger Boost Sensor Circuit. The Turbocharger Boost Sensor is responsible for measuring the boost pressure produced by the turbocharger, which helps regulate the engine's air-fuel mixture for optimum performance and efficiency. This crucial component is typically located near the turbocharger itself, often connected to the vehicle's powertrain control module, or PCM. The PCM utilizes the values received from the sensor to make real-time adjustments to enhance engine performance, and any issues with this sensor can lead to efficiency losses or poor vehicle performance. Proper readings from this sensor are essential for maintaining engine management and emission control systems. Several potential causes could lead to the activation of DTC P0237. First, poor connections or corrosion at the terminals connecting the turbocharger boost sensor to the PCM can interrupt the signal, leading to low voltage readings. Second, loose terminals may result in intermittent signals or no signal at all, mimicking the low voltage condition. Additionally, a faulty turbocharger boost sensor could produce erroneous readings or fail outright, which would directly trigger this DTC. Finally, wiring issues in the harness connecting the sensor to the PCM, such as breaks or shorts in the wires, may also cause low voltage readings and require careful inspection and testing. The symptoms associated with DTC P0237 can significantly impact the driving experience and vehicle performance. Drivers may notice a decrease in engine performance, characterized by sluggish acceleration and a lack of power during driving. Poor fuel economy may also develop because the engine cannot maintain an optimal air-fuel mixture without accurate readings from the turbocharger boost sensor. Additionally, the check engine light, CEL, will likely illuminate on the dashboard, signaling that there is an issue that needs to be addressed. If left unresolved, these symptoms may lead to more extensive repairs and increased costs, highlighting the importance of addressing the DTC promptly. The first troubleshooting step for DTC P0237 is to turn the vehicle to the on position without starting the engine. Then, use the Honda Diagnostics System, HDS, to check the current boost pressure sensor signal against the specified threshold, which should be less than 0.23 volts. If the current conditions align with the threshold, you will proceed to the next step. However, if they do not match, this suggests an intermittent failure, meaning the system might be operational, but experiencing issues such as poor connections or loose terminals. It's crucial to inspect the connections at both the turbocharger boost sensor and the PCM to ensure they are secure, as this could resolve the issue before further diagnostics. In the second troubleshooting step, turn the vehicle off and disconnect the turbocharger boost sensor 3P connector. Next, turn the vehicle back on to check the signal using the HDS once again. Similar to the first step, the reading should be less than 0.23 volts. If the data reflects the expected values, you will move on to step 5 for further diagnostics. If it does not match, you will go to step 3. This process is essential to isolate whether the issue resides within the sensor or another component in the circuit. guiding the technician towards the correct diagnosis and repair. During the third troubleshooting step, after ensuring that the sensor is disconnected, measure the voltage between test points 1 and 2, located at the Turbocharger Boost Sensor 3P connector. The vehicle should be in the on mode during this test. Test point 1 refers to the female terminal number 1, while test point 2 is the female terminal number 3 of the Turbocharger Boost Sensor connector. It is crucial to confirm whether the voltage is approximately 5.0 volts. If this is the case, it indicates that the sensor is faulty and replacement should be the next course of action. If the voltage is not as expected, proceed to the next troubleshooting step to further investigate the wiring in the circuit. In the fourth step, begin by turning the vehicle off and jump the SCS line, service check short, using the HDS tool, and wait for more than 1 minute to allow the settings to reset. Next, disconnect the PCM connector E80P. The next task is to check for continuity between the two specified test points. Ensure that the Turbocharger Boost Sensor connector is disconnected and that you are measuring continuity between point number 3 of the Turbocharger Boost Sensor connector and pin number 77 of the PCM connector E. If continuity exists, it indicates that the wire from the PCM to the Turbocharger Boost Sensor is intact, allowing you to check for authorized service information related to DTCs or substitute a known good PCM. If there is no continuity, it indicates an open wire issue that must be repaired. The fifth and final troubleshooting step entails turning the vehicle off and once again jumping the SCS line using the HDS for over 1 minute. Next, disconnect the PCM connector E80P as in the previous step. This step focuses on checking for shorts in the wiring, as you will be checking for continuity between point number 2 of the Turbocharger Boost Sensor connector and the vehicle's body ground. A successful continuity check here indicates that there is a short in the wiring leading to the sensor, and repairs should address the short circuit in the P3 wire. If continuity is absent, it implies that the wiring is intact. At this point, it would be prudent to further investigate any authorized service information related to the DTCs or to consider substituting a known good PCM, thereby ensuring a comprehensive approach to the troubleshooting process. Once repairs have been completed for DTC P0237, it is critical to conduct a final verification process. This involves confirming that all repair work has been properly executed and that any components replaced or repaired are securely in place. After verifying the repair work, a test drive should be conducted under various driving conditions to ensure that the vehicle operates as expected, without any further issues. Following the test drive, use the HDS to check for any remnants or reoccurring DTCs. This step is essential to confirm that the original fault has been rectified and that the vehicle's performance meets the required standards before returning the vehicle to the owner. Regular preventive maintenance is critical in avoiding issues related to DTC P0237 in Honda CR-V models. It is advisable to perform routine inspections of the Turbocharger Boost Sensor and associated wiring to ensure all connections are secure and free from corrosion or damage. Cleaning the sensor connections periodically can significantly enhance signal reliability and performance. Additionally, monitoring vehicle performance on a routine basis can help identify any anomalies before they escalate into more severe problems. Early detection is key. Addressing minor issues promptly can save time and costs in the long run, thereby maintaining vehicle integrity and efficiency. In summary, understanding and addressing DTC P0237 is crucial for optimal engine management in Honda CR-V models between 2017 and 2022. This low voltage issue in the turbocharger boost sensor circuit can lead to significant performance and efficiency losses if not handled appropriately. It is vital to follow the outlined troubleshooting steps methodically for accurate diagnosis and repair. Timely identification of the problem can mitigate issues related to engine performance and avoid costly repairs in the future. Proper preventive maintenance, including regular inspections and monitoring, will further help maintain the health of the turbocharger boost sensor and overall engine system. Please like and subscribe to the channel. See you next time.